even get to cross.
Baxter is a smart collaborative robot and is safe because it has a mechanically compliant arm with embedded force sensing. Each of Baxter's 7 joints has a spring, and this spring acts a lot like the tendons in your arm. It has give, and we call this compliance. The springs, coupled with force sensors, allow the robot to work safely side by side with people. As the robot is working and a person comes into the work cell, the robot can bump into somebody safely because the springs absorb that energy and the force sensors tell the motors to stop. Then when the person gets out of the way, the robot will intelligently keep working. If the person or the obstruction doesn't get out of the way, the robot can intelligently sense that force and then will signal to its teammates that it needs attention. The benefits of a safe, smart, collaborative robot are that it allows you to minimize the amount of investment required in peripheral safety devices, such as light curtains or safety caging. And it also allows you to maximize your production floor space and your workforce.
Hello, my name is Daniel and today we're going to do the first testing within the ROAR project. So ROAR stands for Robot-Based Autonomous Refuse Handling, and we want to build a robot system which can collect the garbage bins. Now the truck enters the area, and on the rear of the truck we have our robot which is called Rory, and Rory will be the robot which will fetch our garbage bins. And first of all, a quadcopter system will go up in the air and try to locate the bin to Rory. So now I'll go start the quadcopter system on this side of the truck. The complete system uses a map over the environment, and then in the map the quadcopter system will point out bins to Rory so that the robot can find them. The map is also used for Rory to navigate in the environment. So now Rory dismounts from the truck, it will rotate and look towards the area. So now Rory will start to navigate. It uses a sensor which is called a LiDAR, and this LiDAR perceives the environment and tries to find obstacles to avoid. It's also used for localization together with some other sensors. So now we can see that Rory comes in towards an obstacle. So this obstacle is perceived by this LiDAR, and as you can see, it's moving around the obstacles. If there is some unexpected obstacle, for example a child which is running nearby the robot will autonomously stop, because there's an emergency stop system using a set of sensors around the robot. Rory is also using sensors such as GPS and IMU and odometry. So now the navigation phase will end as Rory will be close to the garbage bin. So Rory will stop here for a while, and it will use cameras which are mounted inside Rory to find the garbage bin. And then we are also using LiDAR to continuously track where the garbage bin is and make the robot steer towards the bin. It will extend the arms, and now it will use the other motors in order to extend the bin up in the air. And then it will use its arms once again to make sure that the garbage bin ends up in the top of the robot. So that was a complete pickup. A big challenge within this project has been to develop systems which can operate in a safe way so that no one gets harmed during this garbage collection process. So Sebastian here from Chalmers has been working with one of the systems to make this safe. Can you tell us some more about the system?
Sure. So we have basically automatized the whole lifting mechanism to empty the bin. And in order to make it safe, we have used a camera on top of the truck. If someone comes too close to the lift, the process will stop. If you stay here, we can try it from inside of the cabin.
Great, let's do that.
Sure. So let's try the system. As you can see, we're tracking Daniel now. So below this line is what we're setting as a safety zone. As Daniel is approaching the lift, we will see if the system is working. So you can see as Daniel came too close, the process was stopped here and went on to finish the emptying when he went away. So we're happy with the results.
A very interesting part of this project has been that many students from different universities has collaborated in order to build complex systems. Chalmers has implemented this quadcopter system and developing safe lift mechanism. They have also made a task manager which is used to control the different robots. Mälardalens University has been working mainly with a robot platform called Rory. Pennsylvania State University with a user interface so that the operator in the truck can monitor these different systems in real time and if needed, take control over these different robots. For a first test, I think it was pretty successful.